All right, so here we have our 1.8 notes, our last section of chapter 1. So Philip presents the following number puzzle to his friends. So the number is a prime number. The square of the number is less than 100 and greater than 10. The number is not a factor of 21. What is the number? So Martha states that the number must be 7. Why can this not be true? Simply stated that 7 is a factor of 21. Okay, so I'm going to have you try this one here where write your own number puzzle that has an answer of 5. Your friend says the answer is not 5. How do you use the statements of your puzzle to identify the contradiction? So I want you to try that one. So you may have to pause the video before we move on, and this is something that we will talk about in the beginning of our next class. So using indirect reasoning, Beth is having dinner with Sarah and one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a chicken and spinach pizza to share for dinner. Who was having dinner with Beth? So we want to use indirect reasoning to determine who's having dinner with Beth. So again, there's Beth, Sarah, and then another one of Sarah's friends. So your options are Libby, who's a vegetarian, Mercedes, who is at the library, and Kelly, who's allergic to mushrooms. So obviously Libby's our vegetarian, so because there's chicken on the pizza, Libby's out. Obviously Mercedes is at the library, so therefore Mercedes cannot be at dinner. But Kelly is allergic to mushrooms, and there doesn't say anything about there being mushrooms, so therefore Beth is having dinner with Sarah and Kelly. So again, this is indirect reasoning. So think about this next example. A bagel shop gives customers a free bagel on their birthday. Thato went to the bagel shop today but did not get a free bagel. So using indirect reasoning, again, if you get a free bagel, then it's your birthday. He went to the bagel shop but didn't get a free bagel. So therefore, what we would say is that Thato's birthday is not today. Obviously, if he didn't get that free bagel, it must not be his birthday. So writing an indirect proof by contradiction. So a proof that uses indirect reasoning is simply called an indirect proof. We want to use an indirect proof when I cannot use a direct proof, such as a 2-column proof or a paragraph proof. There are 2 types of indirect proofs where we can either prove by contradiction or we can prove by contrapositive. So let's talk about the proof by contradiction first. A statement's given as some conditional, P implies Q, or if P, then Q. The first thing to do is to assume that P and not Q are true. You then need to show that the assumption, not Q, is going to lead to some sort of contradiction. So then we would be able to conclude that Q must be true and not Q is false. So let's take a look at an example. We want to write an indirect proof of the following statement by using a proof of contradiction. So if Alani walks more than 8 kilometers over a 2-day period, then she walks more than 4 kilometers on one or both days. So what I'm going to highlight in yellow is my hypothesis, and what I'm going to highlight in green is my conclusion. Okay, so we've identified P and Q. So P again is yellow, and then Q is in green. So the first thing we want to do is start off by saying, again, my conclusion is false. So we would say that Alani does not walk more than 4 kilometers. More than 4 kilometers on either day. So we would start off again by saying, assume that she doesn't walk 4 kilometers on each day. So If Alani doesn't walk more than 4 kilometers on each day, then the total distance over a 2-day period has to be less than 8 kilometers. So we'll say this. If she doesn't walk more than 4 kilometers each day, then her total must be less than 8 kilometers. Well, now we've just reached some sort of contradiction here. So again, the what I assumed in the very beginning is going to lead to a contradiction. I would then go back and say that Q must be true. So assume Alani does not walk more than 4 kilometers on either day. If she doesn't walk more than 4 kilometers on each day, then her total must be less than 8 kilometers. But again, this contradicts the original statement. So we'll just say like this contradicts the fact that she walks more than 8 kilometers over a 2-day period. So then therefore, she must walk more than 4 kilometers on one or both days. Kind of ran out of room there. But again, you start by stating something initially. If it works, great. But the point with a proof by contradiction is that you're looking to find some sort of error in your ways. So let's try these. I want you to try these. We'll talk about them. I'm just not going to write them all down. So I'll pause the video and give it a try. So again, we would have, if today is a weekend day, then it is Saturday or Sunday. You start off by saying that today is not Saturday or Sunday. Therefore, today's a weekday. But that contradicts the hypothesis. So therefore, your assumption is not true. So the original statement is true. So again, I'll just write kind of what we would start off by saying. Assume today is not Saturday or Sunday. Again, that implies it is a weekday. And that's going to contradict the fact that we were given, or that we started with, today is a weekend day. All right. So next one, if you draw an angle that's greater than 90, it must be obtuse. So again, start off by saying that we assume the angle is not obtuse. If the angle is not obtuse, then the measure would have to be less than or equal to 90. That contradicts the fact that the angle that I just drew was greater than 90. So the assumption is not true, which means the original statement must be true. Okay, next thing, let's look at a proof by contrapositive. So with a proof by contrapositive, we have a conditional, P implies Q, and it's contrapositive, not Q implies not P. So again, they're logically equivalent. Like we said, whenever your conditional is true, your contrapositive is true. If you prove the contrapositive, we've also proven the conditional. So with a proof by contrapositive, we assume that not Q is true. we want to show that it leads to not P, which shows that not Q implies not P. So therefore, P implies Q must be true. Okay, so let's take a look at one example, and then I'll have you try. Move this up, give me a little bit more space. Okay, so for two positive integers, n and m, if n times n is greater than 16, then either n or m is greater than 4, or both numbers are greater than 4. So let's think about what our original statements are going to be, and then the negations of each of them. So my original statement is, let's say, n times m is greater than 16. So then n times n is less than or equal to 16 if I'm negating that. Q would be that n is greater than 4 or m is greater than 4, or that they're both greater than 4. Not Q would be that n is less than or equal to 4 and that m is less than or equal to 4. So that's kind of what we started off with. So next thing, we would assume, so I want to assume that not Q is true. So assume that n is less than or equal to 4 and that m is less than or equal to 4. So the next thing, if we want to use some properties of inequalities to write equivalent expressions. So if I said that n, let's say if I take this n is less than or equal to 4, if I multiply both sides by m, I'll get n times m is less than or equal to 4m. And then I'll also have, if I multiply this side by 4, I'll get 4m is less than or equal to 16. So then by the transitive property, I would get that n times n is less than or equal to 16. So therefore, this is what I have here. This not Q implies not P. So proving the contrapositive right here, again, so because of this, we have, again, these three dots mean like therefore or in conclusion, not Q implies not P. So we would be able to conclude that P implies Q must be true. So again, when we prove the contrapositive, we're also proving the conditional. Okay, so again, for two integers, n and m, if n times n is greater than 16, then either n or m is greater than 4, or they're both greater than 4. Again, that's the only way that we would be able to solve this problem. So take a look at these next two, the triads here. So I want you to write an indirect proof of each statement by using a proof of contrapositive. So if today is Wednesday, then tomorrow is Thursday. So we assume that tomorrow is not Thursday. So if tomorrow is not Thursday, then today is not Wednesday. So therefore, your contrapositive is true, so your original conditional must be true as well. And then we've got here, if a whole number is between 1 and 4, it is a factor of 6. So again, we want to assume the conclusion is not true. So the whole numbers between 1 and 4 are 2 and 3. They're both factors of 6. So the contrapositive is true, so therefore your original statement must also be true. All right, so we have indirect proofs by contradiction, and we have indirect proofs by contrapositives. So pause, kind of jot this down, take a look at it. Okay, so consider the figure shown and the conditional below. If angle ABC is a right angle and the measure of angle 1 is less than 60, then the measure of angle 2 is greater than 30. A student will prove the contrapositive as a way of proving the conditional. The student plans to assume the measure of angle 2 is less than 30 and then prove the measure of angle 1 is greater than 60. Explain the error in the student's plan. So the student is partially right, but what the student should technically assume, student should assume that the measure of angle 2 is less than or equal to 30, not just less than 30. Okay, so next thing we have, use indirect reasoning to draw a conclusion. So Tamara only cuts grass on the day that it does not rain. She cut the grass on Thursday. So the conclusion I could say from there is that it did not rain on Thursday. Kind of similar to our law of detachment a little bit. Next one, Gabriella works in the library every Saturday morning. She did not work at the library this morning. So therefore, we would conclude that today is not Saturday. All right, and then our last one here, write the first step in an indirect proof for the following. So the measure of angle JKM is equal to the measure of angle JKL minus the measure of angle MKL. So we would start off by assuming the opposite. So assume the measure of angle JKM, instead of it being equal, we'll say it's not, again, because I need the negation, is not equal to the measure of angle JKL minus the measure of angle MKL. So typically, again, indirect proofs, you look at what you're trying to prove and you assume the opposite is true. Keep reasoning logically until you reach some contradiction. So write the first step here in an indirect proof. PQ is perpendicular to ST. We would start off by assuming that PQ is not perpendicular to ST. Just a heads up, that little upside down T means perpendicular, if you weren't sure before. Okay, so that's going to wrap up 1.8 for us.